important part of any kind of research. But nowadays the many data is available. You all heard about the Kaggle, GitHub. So there are many source of data. Maybe this Kokborok the data in a very noisy condition. So you need to eliminate the noise. You need to clean the audio data. And you know, whenever we are cleaning something, we are also deliberately see the spectrogram, see the waveform data. And if you can also insert some kind of noises. I mean, synthetically you can input, provide some noises. If you can eliminate those noises, my audio data will be distorted. Actual data will be distorted. Why? There are many signals, like already in the morning I mentioned, shaw-like sound, this like sound. It's a morely, it's a noise sound. Whenever you delete the noise sound, it will also delete shaw kind of sound. Shaw, haw, there are haw, ghaw, j, ghaw, this kind of sound. They actually erase your audio data. So, data collection and pre-processing very, very important of the data collection part. Okay. Anyway, in the hands-on, I will just take 10-15 minutes to cover few slides on the application, whatever we are doing and why these are important. If you know that whenever we are talking about the application, initially you find it's a very easy task. Okay, I also understand this is like easy problem statement, but whenever we are going inside the problem statement, we will find there are so many difficulties to implement and deploy the solution to the field. Because as an IT engineer, you will also be happy if your application will be deployed and used by some native people. Then you will be happy. You will say, oh, okay, whatever I implement like ISL, okay, I have implemented some kind of website, some learning materials like science. If it can reach to the users, okay, actual users, and they can learn, I will be happy. So that is the most happiest part of any kind of developer. Okay. So anyway, this is one of the project currently we are doing. So this is the current state. Not everything is completed. With IIT Guwahati, our side, and NIT Manipur, this is a consortium project. It's a huge project, and it's within that huge project. This is only the sub project. We are doing the spoken speech technology for the northeastern languages. Mostly we are doing keyword spot. So I am trying to give you the problem statement only and how we are doing. Okay. So the entire slide is saying, if I am think some kind of scenario, I am going to any hospital. Okay. There is no receptionist are there. Okay. But there is some kind of kiosk machine is there. Okay. And the task is to given to you as a patient. You need to speak with the system. There is no other way to give the input. We can give the input touch, type, everything is possible. But the restriction is I cannot type, I cannot touch. Only I need to speak. And I need to speak in such a way I will give the information that I have some problem. I have headache, okay, with some fever, and since last 3-4 days, and I need some kind of appointment with the doctor. Simple, okay. So I need to speak. The system need to understand the major keywords like a fever, headache, and last 3 days I have this kind of problem. But how much serious the problem is? Now the system, AI system will give you, like currently today, these are the doctors are available. Okay, they can treat you for this particular problem statement. Okay, and these are the availability of the doctor. Can you please confirm which doctor can take the appointment for you? Just speak about the doctor's name, and your appointment will be done for that particular day. So this is there are many type of problem and many way to convey the problem. That's the important point. And somebody will say headache, कोई बोलेगा कुछ different, कोई से मेरा headache, मेरा माथा झंझन कर रहा है, ऐसे भी होता है ना. मतलब native people cannot say how they will speak. What are the symptoms? So we thought, okay, so there are many problem statements. We try to reduce the scope of the application. We will try to work on the cardiology role. So if you have any problem related to chest pain, or any pulse rate related problem, then only we will try to help you. Only try to reduce the scope. We will be always be happy whenever we will reduce and try to minimize the scope and try to develop POC, proof of concept solution for the application. So that way we have initiated, and currently this system is not yet deployed, quote unquote, not yet deployed. Is under testing is going on, and Bengali, Nepali, Nagamis, then Manipuri, Mizo, Assamese. These 6 languages. I think there are other one English, Hindi. Obviously, there are other than English, Hindi, there are maybe 6-7 eastern and northeastern languages we are covering in this project to only help out identify the keyword from the continuous sentence, continuous word, or maybe the isolated one. Understood my problem? So this is the project currently we are doing under some funding of the ministry. Currently we are doing with different other institutions like IIT Harvard, NIT Mandi, and other institutions. Currently we are doing. There are 6-7 institutions. The problem statement is speaker identification, scalable application of the identifying the speaker. Okay. And in India Kolkata we are trying to focus on the forensic scenario. What is the speaker? I already in the morning I already mentioned. Identifying the speaker means there is kind of audio data is coming. I need to understand who is the speaker. Okay, but in forensic scenario means I don't have any control over the audio data. I have the data in like a recording to my laptop, but whatever the data, chance data I am getting from the forensic scenario, maybe it's a telephonic conversation, maybe it's a recorded some kind of DAT recorder. So I need to identify the speaker from that narrowband or say low, compressed data. You can say compressed data. So that way we are working for this problem statement. This is also half of the part. Scale deployment of the base level of speaker recognition is already deployed and user agency already they are using. But the forensic part is a little challenging. We are not yet completed. It's with CID and SI and this other security agency currently we are doing. Okay. This is another problem for the autistic child. Those have the problem of the there's a mental problem. They cannot speak well, they cannot behave well, they don't have how to express. So how to identify the autistic pattern within a child without touching or only with the interaction with the computer. Okay. So we develop some kind of solution we call is Disha, where we have developed some kind of stimulus. Stimulus means we are showing some kind of stimulus to the children, and they are reacting on or not on the stimulus is very important. If they are reacting, things little bit okay. We are giving some kind of online scoring automatically, and we are out of 10, not out of 10, out of 40. So we are trying to measure, this is a AI based model. So only thing we have done this kind of stimulus, audio and video stimulus. We are capturing the audio data as well as visual data, and we are trying to capture the facial expression. How he or she is happy whenever I am showing some kind of scenario, happy scenario, and so facial expression, emotion recognition, audio emotion recognition. So and whenever I am giving, instructive tali dao, baja hat tali dao. So if he or she is following my instruction or not, this way we are trying to capture the audio sound and analyze. So this way we are working of this Disha project. This is completed and we deployed our solution in different NIPIT-like institutions. NIPIT basically is under Ministry of Social Justice and Empowerment. There are different institutions where these are, the child come to that kind of institution for the rehabilitation or therapy. Okay, we deployed the solution there. So anyway, I am not going detail. There are so many things. Only thing. So why I am showcasing this application? Because in the morning, whatever I have shown you, that are the basic things. With the use of those basic information, we try to develop some kind of application for the society, and that should be deployed for the user premises, and we are in a position to guide them to children, to the parents, how they can use this kind of application. So, and this kind of application is successfully running. Okay, so I am not going details. There are so many. Try to see anything special or not. So this is another important for the data purpose. For the data hungry people, for the speech, these are kind of audio data we have created. Bengali, Hindi data is already available in the website also, where we have collected so many of data for Hindi and Bengali, and these are the transcription tool we designed and developed in below right side corner. And so annotation is very important. So whatever we spoke, sometimes we cannot speak well. So we need to annotate. So this way we have implemented this, capture the data scientifically and annotate, and it's available for the speech recognition and text to speech synthesis application. Okay, this is another application for the Tripura. It's a long back in Tripura. This Nodoshindo God, there is one place. Near in TIT college. So it's around 2017 or 18. We developed that Bengali text to speech synthesis system, Bengali speech recognition, as well as Bengali phonetic keyboard. So we deployed the solution these blind schools, okay, under some funding of the ministry, and we developed, deployed 2 labs. One for boys school of, IVH school for boys, Institute of Visually Challenged School for boys, and Institute of Visually Challenged School for girls. So we developed 2 labs there. We have given laptops and all accessories, and we deploy our solution, and we train them how to use those software, okay, for your learning. Okay, how you can type in your mother tongue. Okay, so this is one of the things we have done here. This is another application we call as Ishara. Why I am showing it's a similar related to the ISL of Kokborok language. We also have some Bengali e-learning tool for the sign language, where we develop those sign languages e-learning tools and deploy in different special school in West Bengal. And this is desktop and web browser and mobile based application. It's mostly we have collected, like in the morning we have seen some kind of data you are showing. Similar way, some data we have also collected from the user. I mean, there is a school, National Institute of Hearing Impairment under Social Institute of Minister of Social Justice. We are in a collaboration. So on that project we have there is a collaborator with us. So we have collected so many these signs in the Bengali language, and we share all those data to all the schools. These 32 special schools for only for the for understanding how to how to they can learn the sign language. Okay, good. Few slides more. So these are the different instruments we have in our lab. First one is a mini PG system. This is basically we have one project on articulated phonetics. You know that wherever we are pronounce consonant, they touch. I mean, our tongue touches some location of our hard palate or soft palate. So this is a mini PG system. With the mini PG system, there is an artificial palate designed by not us. It's some USA-based company. So we are given some kind of denture, and this kind of palate is prepared by some foreign institute, and we are wearing this kind of mask, okay, as a hard palate, and whenever we are pronouncing some kind of consonant or vowels, our tongue touches some of the portion of the sensor. There are different sensors are there, okay. Say, and these sensors is like this is the front side of your tongue, and this is the back side of your tongue. Imagine, and this is your teeth. This is the teeth side, okay. This is the alveolar, post-alveolar, palatal, and the velar position of your tongue. Whenever we pronounce some kind of consonant, not vowel, so our tongue touches some of the location, and which location is like a paw. For the paw is for the velar sound. Most of the time we have seen like a black region for this part, on the velar part. Okay. So there is one experiment we have done. So that's why this instrument we have purchased. This is the nasometer or nasal sound measure equipment. Most of the few of the sound in Bengali they have like a nasal sound, like a no, no, this kind of sound. How much nasalence is there in my sentence or my words? That's a measurement. And apart from that, this is the audio recorder, this is a headphone, some sound card, mixture is very important to set up in lab. So anyway, we organize different workshop, training program for different areas of machine learning and AI on speech, image, and video processing. So recently, 2024 March, there is an industrial training program we organized. Apart from that, the ISPA 2021 is long back, but it's a very important, like a 5 days we organized this kind of workshop and training session for the students and the faculty members. Some achievement of our lab. There are many collaborators across the country and outside of the country also with us. Most all the IITs, mostly NITs, central universities, and ISL Bangalore. Those who are working in the similar area, most of the institutions we have the collaboration, and currently we are doing and executing different projects. Maybe some projects are already completed, maybe some projects are ongoing, but we have some kind of collaboration with that all the operations. With the Tripura University also, with Sunny sir, we have started some work long back, and DIT also. These are the contributors of my team. Okay, so Professor Basu is a very senior professor from IIT Kharagpur. He's a retired professor, but still he is so much active. His age currently maybe around 80, but he is still so much active. Okay, so that's all from my side for the past part of the pending part of the model. Okay, but I skipped so many slides. Okay, so hands-on is always two-way. Whatever I will do, I will teach you, you also do that. But here it's a one way. So I will do, try to capture in your mind and do it whenever you will get time, if you are interested. Okay. So hands-on with the signal, speech signal, it's really interesting. Okay. I just try to skip some slides here. This is not required. I'll start from here. There are different tools are available to record your audio data. Okay. Tool Edit Pro, Wave Surfer, Praat, Wave Analyzer, Sonic Visualizer. There are so many. Okay. But within that, always we prefer some open source. And Praat is such a tool. The number one, Praat is such tool. We always prefer the students will start using Praat. Okay, because if you use the Praat, it's a free and open source. Nobody will claim whatever the result you will receive. Internationally, all the researchers are using this tool. Apart from that, we use in our center, we use the Tool Edit, this one, as well as Wave Surfer. Apart from that, Praat, we use the Tool Edit and Wave Surfer. So here for the understanding purpose, we use only Praat. Okay, so that you can at least you can get some input from my side, and it should be taken away from your side. So Praat, I already mentioned, is an open source, okay, and very flexible. Do any kind of acoustic analysis. You can record your voice. You can change your voice. You can remove the pitch pattern from the audio file. Whatever you have recorded, it's an annotated file. But I can remove the pitch, so it should be flat. So we can play with this Praat, okay, in many ways. Okay, and Praat, they have their own scripting language. Though all of you know maybe Linux, shell scripting, PHP scripting, these are all scripting. So here also they have their own scripting language. So you can also write your own programming using Praat. Okay. But today we will only talk about initial Praat. How we can use, how we can record, how we can annotate. Because I feel here maybe few of the students have the understanding about the speech data. So I feel that if we can start how to record your voice, the first question, and how it looks like, that's important. How we can annotate those data. Whatever I am saying, I am from Kolkata. So I have recorded, I am from Kolkata. 4 words, the different phonemes are there. How we can record, how we can annotate. How annotation is very, very important. Why annotation is important and how can do that. Okay. So that's why I am trying to show you some kind of Praat annotation also. So I am going directly to the Praat. So it may be better to. I think I have Praat over there. Okay. This is my Praat window. Okay. So this object window is not required right now. So I am closing. So this window is this is a design window. This is the object window. So this window is important for me. Okay. So what I will do, I try to record my voice. Okay. This is my first task. Okay. So record mono sound. What is the mono sound? Mono means single channel. Stereo means 2 channels. Left channel, right channel. Do you have any idea about the left channel, right channel? So in recording studio, most of the string instrument or singing, when it's performing the singer, it can be recorded in multi-channel. Singers singing in a 1 channel, guitarist playing guitar in different channel, then tabla is going on different channel, recording is different channel, so that I can remove anytime any channel. I can mix any other data. If I can record some other instrument in different channel, I can mix. I can produce a single audio file from the different maintain different channel recording. But here in this Praat, we have like a only two channel recording is possible. Two channel means my left and right. This is a, in your laptop also there is a left and right balancing is required. Left mount, I mean what speaker and left right speaker. Two sides of speakers are there for the two channel. But we will do the mono channel recording. We will start. Whenever we will start, it will ask me what are the different channels. Already I have selected mono. Sampling frequency is a 44,100 hertz is selected by default. So what is that? What is that? Sampling frequency is in our audio data we can produce maximum 3.4 kilohertz signal maximum. Say roughly 4 kilohertz signal. Sampling frequency should be twice of the highest frequency as per Nyquist rate. So 8 kilohertz. If I say like a 4 kilohertz signal I can produce, but I cannot have anyway. If I can produce 4 kilohertz signal, then the sampling frequency should be 8 kilohertz. So we will take 8 kilohertz as a starting point. 8 kilohertz as a starting point of the audio recording. That's why 8 kilohertz is the starting point. 8 kilohertz is the starting point. But sometimes some female speaker can speak higher frequencies. Can speak in higher frequencies. Maybe sometimes maybe 4.1 hertz, 4.1 kilohertz. So that way 4.1 into 2 is a 8.2 kilohertz. So 8,000 hertz may not suffice. Okay. So preferably we will record our audio data 16,000 hertz or 22.5 kilohertz. So these two we sometimes choose for the recording for audio data. Most of the data, available data is the 8 kilohertz sampling rate, but whenever we will do the recording our voice, we will try to capture 16,000 hertz or 22,050 hertz. Whenever we will record the music, it should be higher because the string instrument and other they can produce the higher frequencies, and we will prefer 44,100 hertz for the music. But for the audio data recording, it's not required. 16,000 hertz is sufficient enough to record any human voice. Understood? So we will choose 16,000. And there is a record button. I will try to speak. I don't know if it will record my voice or not right now. Hello. It's recording. So it's a bar is showing that I am recording, and green is allowing. But whatever the threshold of the bandwidth, I am below the bandwidth. But whenever I will try to produce the higher energy, some kind of yellow bar is there. Okay, I can also touch the red bar. I may not. Okay, but then the yellow, the red will also show. Okay, so I am stopping here, and I can give some name here like a JB test. Save list and close. Save list and close means it will save the list in the list and close the window. Sound underscore the same sound JB underscore test. I have recorded. I can just view and edit. So this is my recording. This is my audio data. Whatever currently I spoke. So I just try to play. Oh, hello. It's recording. So it's a bar is showing that I am recording, and green is anyway whatever I speak. So it's a recorded my voice. Okay. So this is my natural data I have recorded. So now my interest to zoom some of the portion. Okay. In below, all in, out, cell, back. All means it will zoom all the spectrogram. I mean all the wave file. In means zoom in. Out means zoom out. Is it visible? In means zoom in. Out means zoom out. Cell means zoom the selected portion. I have selected some portion. So if I click, this section is only zoom. Okay. And back means back, zoom out, zoom out, zoom out. This way. So portion, okay? Then what is this red dot and what is below, okay? First of all, no red, no yellow. It is called a spectrograph. This is called the spectrographic view. This is the time versus amplitude. This is time versus frequency versus intensity. It's a 3D plot. Time versus frequency versus intensity. If there's a black portion means high energy, there's a white portion means less energy. If you see, this is the some of the consonant. I try to speak only now. I will record some only one or two words to give clear demonstration. Okay, so it will be better. I just closing now. I try to record again. Okay, new mono 16,000. Only I speak some vowels and some consonant. Okay. O, A, E, U, O, Ko, Kho, Go, Bo, Mo, No, Lo. Okay, so these are some segments, vowel, consonant. I've recorded some vowels and consonant. So these are the segments of different vowels and consonants letter. Okay, I'm just playing. O, A, E, U, O. Then stop it. Okay. Then I try to zoom only O. This is my O. If I play it, O, only O. Okay. So just try to understand. This is actually O fade in and fade out. This is actually O. So you see, there are some kind of signals are there. Okay. But if you see, there is no highly intense darkness are there like this. This is missing. This signature is missing here. This is only for the pure vowel sounds. This is maybe vowel, may not be vowel, some transition. We call it a transition. Consonant to vowel transition, either noise to vowel transition. So that's why this kind of pictures we are showing. Okay. This is some kind of intensity. Here is some intensity. Some white portion is there. Again, this section, we are seeing some kind of signals. In time domain, there are some signals are there. But in below, there are mostly white in nature. Okay. Frequencies are there. So below is the spectrum, frequency components. Frequencies are there, but intensity is very less. Okay. Now I zoom a little more. I'm taking this this section only. See, now this signature, whatever I am showing, I mean checking here, kind of is a sine and cosine mixed signal. So though, this kind of periodic signal, okay? Why periodic? Try to capture the periodicity. Look at the signature. I have selected some portion. This is repeated. Please check. This section, the selected section is repeated every time. Maybe some slight changes are there due to some different artifact, but some similar, like a some kind of repetitions are there. Okay. So this is a pure vowels. Is this board is working? Yes. Pin. Understand my point? So these are the very basic of the speech data. That's why I am showing. Maybe some of you it's already known, but some of you it's not known. Try to understand and try to visualize. These are the vowel section. Okay. If I play only this section, it's very select this. Here you just check. This section is repeating multiple times. The selected section is repeating multiple times. So it's kind of quasi-periodic in nature. Not absolutely periodic, but it's a quasi-periodic in nature. Some periodicity is there. So if the periodicity is there, I can extract the fundamental frequency F0. I can extract the Foreman frequencies. What is those? So here pitch, shoe pitch. It's a flat pitch. Flat pitch, because I cannot speak a single vowel in different pitch pattern at a time. When I am producing O, I need to speak like a 167.3 hertz. 167.3 hertz is mentioned. It's a staying at a flat pitch. But whenever we will check like a O or E or U, other vowel, small segment, or whenever we will plot this pitch, maybe it's little high, like a 187 hertz. These are the values and extracted parameter from the raw data to C is defined. Whenever we try to extract the information, that means we are extracting the pitch values from the audio data and put it into the Excel file. Okay. So I can plot the pitch data here also. Pitch listing. So select import data. Sorry. Select. Check, these are the very static pitch. Okay. Not very higher. Okay. It's around 169.5 hertz. It's a flat data. I can plot here. These are the different, whatever the selection I am showing, these are the different pitch values in different time. 1.172656 থেকে 1.182, around 10 milliseconds. 10 milliseconds voice is plotted. It extracted the data of the pitch value for the 10 milliseconds. Okay, and it's a giving 171, 171, 160. These are the hertz. This is hertz. Okay, these in hertz. These around 160 to 170. Little variation. Okay, and I can also show the format frequencies. What is the format? It's a resonating frequency. It's a resonating frequency. Whenever I touch our vocal tract and produce the different vowels, it is producing some kind of resonating frequency. Fast format is the below, this one. Only this is below red dot. Fast format. This is the second format. This is the third format and this is the fourth format. Fast format is the fast resonating frequency. F2 is the second resonating frequency. Higher frequency component where good resonating, good energy is there. Okay. So this way we can plot, and every vowel they have the different F1 and different F2. Using fundamental frequency, fundamental frequency F1 and fundamental frequency F2, we can design a speech recognizer. Only these two features we can implement a vowel recognizer for the audio data. That is possible. Only two features. Then this is for what? E. Okay. Try to check the E. E. Okay. Format. P. 196. Or for the O, we have seen around 165 to 171 the range. But for the E, around 200 hertz. It's a higher frequency, higher fundamental frequency I produce at the time of production. Okay. And if you see this kind of section, it's a clearly mentioned this kind of signature is repeating. Signature is repeating for the vowels. Okay. So for the vowels, this kind of signature is repeating, and all the signatures are different. But the signature of O is different with signature of E. Okay. Okay. What is that? Ko. Ko. Okay. Ko. Interesting. I will stop here. For the ko, it's a very interesting But this sound is basically O. There is no ko. No, not K. I mean, there is a no K in this selected region. Only this selected region is basically ko, K sound. So signature of the ko is very interesting. Okay. Signature of the ko is very interesting. The pure silence, then small burst, then BOT, then R. Up to this is K. And after that, this O sound is starting, then again fade out. This is pure O. And this area, I mean, from here to here, this area basically ko and O both are there. So transition from one phoneme to different phoneme. So that's why you see this region closely. This region closely. This is white. No signal. No signal. Nothing. It's like a straight line. Okay. Then after some kind of hesitation started. Some higher frequency component. This is we call it as a Basu. It's a Basu. Then again some white portion. Then transition started. Transition means white and black mixture. Where this blue line is started, na? This is blue line is started. This blue line. This is only for the O sound. This blue line is not exist here. Ko, they don't have any excitation. So that's why from the ko sound we cannot extract any pitch value. Okay. So this is the signature of ko. Understood? Any question? Okay. Mo. You will see again mo. Mo. This is M sound. This is mo and O transition sound. This is pure O sound. And this is mo sound. Mo. মায়ের মধ্যে যে শুধু ম সাউন্ডটা থাকে ম সেটা হচ্ছে এটা and you see that blue lines are here. Blue lines means pitch. So mo is a consonant where we can extract the pitch value, but from ko sound, ko is also consonant, we cannot extract the pitch value. So using the Praat you can extract the information, and all those information, all this pitch value you can plot it. You can take this information and you can plot. I mean, you can copy and paste in the Excel file and you can plot. So that's your data, and that's your starting point for the CSV files. We can write a program, Praat script, Python script, any script, scripting language we can write. But from the raw data, from the using Praat, we can extract those feature points. Okay. And if you see the intensity, yellow line is the low intensity mo is here, high intensity in O, then again fall. Okay. So whenever we started working on the audio signal, we need to record our own voice first, vowels and some consonants, and try to understand what are the different component of the audio files are available. So that's a very important, because within that there is some physics are there, some mathematics are there. If you go deeper, there are some mathematics are there. Like entire vocal track model is a complete mathematical model. Okay. Interesting. Board লাগছে খুব পাচ্ছে। No. No is same like mo. If I can select it, this is no. Only pure no kind of sound. If we can select this sound and this sound, this is a no. No. So this is the, then I need to select the audio file and text file both using pressing the control and click the view and edit. So this is my audio file, whatever I have recorded, okay. And below this is the word I have recently I have given the name of the word I am putting. So why word? Like I need to annotate. What is the meaning of the annotation? Annotation means whatever I am speaking, I need to mark in a Roman. Okay. So this is my O sound. Okay. And before that maybe silence are there. So this is O sound. I will come here and this is the starting point of O. This is the ending point of O. I can write this is O sound. Okay. So this is A. So this is the starting point of A, ending point of A. So I can write. I can put it here. Start point. This is the end point. I can write. This is A. Okay. A is maybe we can write this way. Okay. Or this is what is that? E. E. So I can write E. So starting point. I'm clicking just this point. E. Starting point E. Sorry. E. End point. I'm writing I. Okay. So this is different. Go. So go. So go and O is there. So starting from here is the go and end is here, around here. So I can write go and O both. But there are two phonemes. Okay. So I just select it again and zoom it. Zoom it. This is a go on. This is the word. But go starting from here. Okay, and ending from here. So I try to give one input here, starting, and this is ending of go. This is only go sound, and this is, I can say this is a transition. So I can mark as a go and O both. Then this is pure O. Then I can mark as a O, and this is we can reduce the sum. Reduce it. This is again end. So I can mark as a O and go. O and not go. Pure O or O maybe fade out. Out. O out. O out. Understood my point? This is pure go. Okay. Then go R transition. Then pure R or O sound. Then go out. O out means O fade out. If I can save it, it will save as a text file and as a JSON file. Okay. Okay, where it is, I can put it. I can put it somewhere. Like so I just save it, replace it, and close it. I not yet save my audio data. So I need to save the audio data. So audio data I need to save. Okay. So I also save the audio data as well as text data. Now I try to open this text file. Very important. As a this is my text JSON style, or maybe it's an XML style. Okay. So this is xmin minimum value and maximum value in second. So this is the tier, word tier. Okay. So whatever I have annotated, everything is there. This go sound, go. This sound is starting from 14.5 seconds and ended in 14.9 seconds. This is a go sound. Okay. After that, 14.90 से लेकर 14.93 तक go और transition sound, and again 14.93 take 15.10 is all pure O sound. So this way we have saved the data, and we can write any program and extract the extract the features or extract the information of pure O or pure R. Okay, so this is very helpful, and we are not writing this data. Praat is writing this data after the annotation. Okay, and this is a structured data. And as a programmer, we will be happy if anybody can give this kind of structured data. We can write an kind of parser, and we can extract the information whatever we need. Okay. So this is Python or maybe the Praat script, you can extract all those information from the text read and audio file and you can write in a CSV file. Because currently all the, whatever we have done, analog to digital conversion is done. We have seen the sampling frequency, everything, we can record our own voice. Okay. Then we have already digitized our audio data. Now we have, annotating those data where the O, A, or vowels or consonants are there, and save it in a text read file. And also we are showing that pitch values are already there. So we can write 1 to line of the code of the Python, in Praat. So you can extract those information easily. And whatever this website I shared here, so just go to that. Just go to praat.org. All the codes are already given. Sample codes are already given. For the initial, you only record your own voice and they have given the code, you just execute those codes. Praat script. Extraction of the pitch, extraction of the fundamental frequency, extraction of the format frequencies, energy, everything is like, it can be extracted from the audio data itself. So these are another important tool, Weka. আমরা তো অনেকেই জানি তো Weka নাম শুনেছি? Weka নাম তো শুনেছি আমরা? কি করে? হ্যাঁ? বলো না।
পাখির নাম।
হ্যাঁ?
পাখি।
হ্যাঁ ঠিক পাখি একদম ঠিক। বলো কি করে?
মেশিন লার্নিং অ্যালগরিদম।
মেশিন লার্নিং অ্যালগরিদম পারফর্ম করতে সাহায্য করে। So Weka and Python actually আমরা কি করে ডেটা কিভাবে তৈরি করতে হয় আমরা অলরেডি we have seen. How to produce the data in কিভাবে নিজে ডেটা ক্রিয়েট করব, কি করে অন্য ডেটা রেকর্ড করব, আমরা মোটামুটি একটা বুঝতাম। But if we have the enough amount of data, we need to write some kind of thing like madam asked how to populate those CSV file data. So we need to write some program. So Weka and Python is very important for the user-friendly interface, or maybe you don't bother about, you don't want to write any code. Then you just go ahead with the Weka. You need not write any one line of code also. Okay, you just import the CSV file or import the data, and you can create your own machine learning model. And for the Python, you need to write some lines of code. Okay, but Weka at a disadvantage, it cannot load the huge amount of data. If you have like 1 lakh of data, you need to load in Weka. It will take huge amount of time because it load in memory only. It will load on RAM only. If you have the RAM size is huge, then only it's possible. Otherwise, it's not possible. Then Python is good. For the student, if you have recorded your data using Praat and you have extracted the data and put it in the CSV file, you need to do some kind of machine learning model. You can use Weka fast, not an issue. Okay, you can also extract the information from the Weka. There are different machine learning tools are there already, so you can just use those tools and generate or publish the paper. Nobody will stop you. But if you do anything more beyond that, you are trying to implement some kind of solution, then Weka is not a good solution. For that, you need to go for the Python. Okay, so Weka, I will also try to show the Weka if you are interested. So there are different options like Explorer, Experimental. So different options. If you have small amount of data, then Explorer option is good to use. So already this Weka, they have given some kind of CSV file, not CSV. They have their own annotation file, ARFF format, R format. So you can also import. Some data is already there, I think so. Some data is already there. These are some data. Okay. So I just import some data. Okay. These are already given data. If you install the Weka, this is also free and open source. If you can use the Weka, nobody can stop you. You can publish the paper, you can write the name of the Weka. So you can say like I have used the Weka, nobody will ask the license. you write the Praat, nobody will ask you the licensing of the Praat, because somewhere you need to mention it's a free and open source. Give the proper acknowledgement of the author. Okay, that's it. But if you use like I use the MATLAB, that is I mean reviewer may ask what is the MATLAB version. I mean, do you have the license? So that's the question. Maybe sometimes we don't have the license version. Okay. Anyway, so these are the some I mean imported data I have already imported. This is the outlook, temperature. This is the weather data. So outlook, temperature, humidity, windy, and plain. So problem is something like that. If the outlook is sunny, overcast, and rainy, temperature is varying, humidity is varying, windy is there. Can we play or not? Yes or no? Something like that. I think so. So it's the outlook. It's sunny, overcast, and rainy. Temperature is hot, mild, and cool. Humidity is high and normal. Windy is true or false. I mean, it's a windy or not. And can we play or not? So this is play for 9 times and no for 5 times for different scenario. Okay. So I need to, I mean, we can import the data, we can build the model easily. For that, we will go to classify. We will choose different kind of functions are there, like a SVM or maybe some basic function. Maybe we can try first. Yeah, the multi-layer perceptron is also there. This is a multi-layer perceptron. Okay, maybe start with some SVM. Okay, so these are different way of doing the thing. This is a cross validation is by default 10-fold cross validation. We can also split the train data with test data. Most of the time we will do 80-20% of training for the 80%, 20% for the testing. Most of the time we will do. So we can do the same thing. We can do the cross validation. Okay, 9. It will divide it into 10 different folds. 9 folds for training, 1 fold for the testing. Similar way, it will take all the folds for the training and one fold for the testing. So simply we need to start here. So immediately it will give you some kind of classification problem. Okay. So it's a yes. I mean play yes. It's absolutely correct. This is a 9 out of 9. It's 100%. It's showing some kind of faults are there. So this is the errors. Some errors are there. Okay. So similarly, I can choose different multi-layer perceptron. Then I can start it. Then I am showing here 7 times is showing correct, 3 times is showing correct out of 9, and 2 times is failed to classify the data. Okay. So this way I need not write any lines of code. I just choose any kind of classifiers, input the data, and if I need to do any kind of pre-processing, we can also do the pre-processing at this pre-processing level and do the classification. So it's a very simple. So if you have the data, some amount of data like 5,000, 6,000 data if you have in this format, ARML format, then you can easily do some kind of classification without writing any code. Okay. So is it okay? So should I stop here? Do you have any question for sir? Those who will be working on the speech or natural language can. It can be used for the any. If you have any kind of data, you can just import it. Only you need to follow the template. I mean, they are not taking the CSV file as an input. They have their own data structure. So only need to go for their data structure only. So that is also structured data. One pattern to another pattern. You need to change.
Those who have data in CSV